We'll discuss about the third case of Frobenius method, okay, in which the roots of the initial equations are are distinct and their difference is not an integer. Okay, so let's start today's lecture. So third case, when the roots of initial equation are distinct and differ by an integer. Differ by an integer means m1 minus m2, you will get some integer. Okay. So let you have m1 and m2 be the roots such that m1 is less than m2. Means when we are saying that their difference is an integer, so they might be the real numbers like 2 and 4, like that. Okay, so that the difference is always an integer, but it's not the case. Even you can get 3 by 2 and 1 by 2, so difference is again you will get 1. Okay, but what I'm trying to say is, when we have two roots and these two roots are real numbers, and if their difference is integer, that means you can compare these two real numbers, or real numbers you can compare every time. Compare means one should be less than another one, right? So when we have two numbers, two roots, so one should be less than another one, or you can say that another one is greater than the first one. So always take m1 as the lesser root and m2 as the greater one. m1 and m2, right? That means m1 is less than m2. If sum of the coefficient of y series become infinite when m is equals to m1. See, for the first case, when we have discussed first case, roots of the initial equation are distinct and their difference is not integer. So the solution that time was C1 value of y at m is equals to m1 plus C2 value of y at m is equals to m2. So that was your first case. Your second case was when roots are equal, m1 is equals to m2. Then solution was C1 value of y at m is equals to m1. Means both are equal, so let us consider at m. Then C2 will take a partial derivative of y with respect to m, and then we'll substitute that root. This was your second case. Now your third case is when the roots are distinct and their difference is an integer. Okay, so when we substitute y is equals to this first root, okay, like, and to find first solution, C1 y1, then value of y at m is equals to m1, and any of the terms is going to be infinite when I'm substituting m is equals to m1. Then what we do here, we modify the form of y by replacing a naught by b naught m minus m1. The root at which the term of y is going to be infinite will replace that. That means if we multiply the whole y with this factor, that means it will be cancelled out and cancelled out. So when you substitute m is equals to m1, any term of this won't go to 0, will not tend to 0. Okay. So then the complete solution is this. It will be clear by this example. So this C1 value of y at m2. m2 means first we substitute the greater root. That is your first solution. Then we'll take a partial derivative with respect to m. Then we'll substitute first root m1. Okay. Now obtain the series solution of this equation. Suppose you have this differential equation, right? Now this differential equation, that means Px value is coefficient of dy by dx minus 1 plus 3x divided by x into 1 minus x. Qx value is minus 1 over x into 1 minus x. Now you can see that at x is equals to 0 and 1, both are not analytic, not defined even. That means x is equals to 0 and x is equals to 1 are the singular points. Now singular points, so let's check for the regular singular points. Okay, so we'll check for x is equals to 0 because it is the simplest case. So let's multiply with this x and x will cancel out. At x is equals to 0, you will get 0, 0, minus 1. Finite value, x square. So that means you will get x here and this x will be cancelled. That means 0. So both are analytic at x is equals to 0. That means x is equals to 0 is the regular singular point. Now, assume that y is equals to 0 to infinity a n x power m plus n is the solution of this differential equation. So this is the summation form. This is the expanded form, right? Now first derivative already we have discussed. Take derivative with respect to x. M a naught x power m minus 1 and so on. And then second derivative. Okay, once you have these values, substitute in the given differential equation. See, x1 minus x value of d2y by dx square minus 1 plus 3x value of dy by dx minus value of y. Now, first step is search for the lowest power of x. That means this is term is x minus x square. So when I am multiplying with x, so 1 power will be less, right? So here you will get x power m minus 1. Here you will get x power m. Here you will get x power m plus 1. Sorry, 1 power will be increased, not less. When I am multiplying with x square with this term, so 2 powers will increase. So x power m here, x power m plus 1 here, x power m plus 2 here, right? So overall we have, so far this is the lowest power of x, because when you are multiplying x and when you are multiplying by x square, 2 terms you will get. Now let's multiply by 1. So 1 means lowest power is x power m minus 1 only. Here x power m plus 1. Let's multiply by 3x. So when you are multiplying by 3x, lowest power will be x power m. You will get x power m here, x power m plus 1 here, x power m plus 2 here. So overall the lowest power is this. Let's check here. Lowest power is x power m. Now from concluding all these terms, the lowest power is this one, x power m minus 1. That means we have to compare the coefficient of x power m minus 1, and that is we need to equate it to 0. Okay, so let's search for that. X power m minus 1, when I am multiplying this with this, right? So m minus 1 a naught. When I am multiplying x square with this, we will get x power m. So no other coefficient will get. When I am multiplying minus 1 with this, then only we will get x power m minus 1 coefficient. So minus m a naught. Then when I am multiplying by 3x, you will get x power m. No need, no. So only these are the coefficient of x power m minus 1. Equate it to 0. Take a naught common. Minus m, 2m. A naught cannot be 0. First term of this assumed series, it cannot be 0. M minus 2 is equals to 0. That means m is equals to 0 and 2. See, roots their difference 2 minus 0 is equals to 2. Integer, right? So let us take m1 is 0, the less one. M2 is 2. Now keep this in your mind and just move further by comparing the second lowest power of x, that is x power m. So when you are comparing the coefficient of x power m, you will get a1 in terms of a0. Like in this, just compare the coefficient of x power m both the sides. Then comparing the coefficient of x power m plus 1, m plus 2. That means you need to find the coefficients a1, a2, a3, a4 in terms of a0. So value of y is this. Okay, value of y is this. Now see thus what was the solution. I will write here y is equals to c1 value of y at m2 means the greater root, then del y over del m and its value at first one with c2. That means let's substitute m2. m2 is 2 here. So when I'm substituting m is equals to 2, greater of the two roots, you'll get this. Now let us check. Put m1 is equals to 0, m is equals to 0, second root. Okay, so when I'm substituting m is equals to 0 here, this term 1, fine. This term minus 1, okay, fine. This term, see, it's going to be infinite. This term is also going to be infinite. Okay, so what we do here, see, now read the statement. If sum of the coefficient of y series become infinite when m is equals to m1, we modify the form of y by replacing a0 by b0 m minus m1, that root. Okay, so what we do here, we'll replace to find the second solution b0 m minus 0, that means simply m. So when we multiply m from outside, you will get m here, m here, m and m, that m will be cancelled out, this and this m will be cancelled out. So when you are substituting this root, it will not go to infinity. Okay, see here, if we put m is equals to 0, the coefficients become infinite. So put this, so that this. Up to here, clear, right? We have replaced here a0 by b0 into m. M we have multiplied inside. Now second solution was c2 del y over del m and value of at 0, right? Partial derivative with respect to m. Now when you are doing partial derivative with respect to m, that means you have to treat x as a constant. Partial derivative means partially differentiation, treating another variable as constant. Now same, a power x differentiation, a power x log a, right? Means this log a. So here consider this as first and this as second. So first one differentiation, b0 is constant, x power m. M is variable here, treat x as constant. Okay, that means a power x. So x power m log x, right? X power m log x, and the same term. Then this same and differentiation of this with respect to m, right? Then put m is equals to 0. You will get, hence the complete solution is this. So this is your solution. Now we have Bessel's equation. I want you to solve this equation, Bessel's and Legendre's equation. Please note down this form: x square y double dash plus xy dash x square minus n square y is equals to 0. Once you have completed, then I'll upload this material. Okay, so solution series is this. Differential equation is this. Now, and already include here. First thing is you need to remember the form of Bessel's equation. This is the named equation and very well known equation. Okay, so remember the form of this. Even in the exams, if the question is solve the Bessel's equation using power series method, that means this form of the equation will not be provided to you. You have to remember the form. Okay, so now you can see that x is equals to 0 is the regular singular point here. So if I assume n is equals to 0 to infinity a n x power m plus n. Now n already includes here, right? So we'll take m. M is equals to 0. In place of n we'll take m, and in place of m we'll take k. So this will be your assumption. I have snipped this from one book. So in place of A's, they have taken C. Okay, so notations means that should not affect your concepts. We can take any notations. Now here they have solved in the summation. You can use directly with this. Y is equals to, you can use this form only. For it should be m a naught x power k, a1 x power k plus 1, a2 x power k plus 2, like we were solving. You can use the same method. And if you are using the summation method, see first time derivative with respect to x, k plus m, x power k plus m minus 1. Second derivative, k plus m, this is nothing, k plus m minus 1, and k plus m minus 2. Then substituting these values. Okay, and when you are substituting, they have separately take x power k plus m coefficient once and separated k plus m plus 2 coefficients. Okay, so I want you to solve this question without using the summation, expanded form itself. Okay, I will upload the slides. It's not that important, but we should know how to solve. Next is Legendre's equation, that also you need to complete. This is your assignment or homework, you can say. 1 minus x square y double dash minus 2xy dash plus n into n plus 1. Okay, here please remember the thing is, when we have 1 minus x square y dash, see here x is equals to plus 1 and minus 1 are the singular point here. See, so we'll take x minus 1 if we are finding around point 1. Let us take t. Just I do not want to write the series in this form. An x minus 1 power k plus m. Okay, so x minus 1 power k plus m. X minus 1 power k plus m means simply take x minus 1, means just change this origin. If it is series solution around x is equals to 1 point, by assuming t, that means it is around 0. Like in place of this, you can write t power k plus m. Okay, so once we get the solution, we'll simply replace t by x minus 1. Because around origin or around 0, it is very simple than this. Now we have chosen this. That means you have to take x power k minus m instead of k plus m, because here if I find the value of t, right, because I want x is equals t is equals to 0. So when you are substituting t is equals to 0, that means x has to be 0, right? So t powers will be negative in form. So t powers negative means, see here, it should be negative. So that I want to understand, I want to make you understand this form. Then the same procedure. So I want you to complete these two questions. Then your module, this is the last topic of your module 5. In the next class, we'll discuss solution about this, and then we discuss the Z transforms. Okay. Any doubts? No doubts. So I'll take your quiz on Friday. Okay. Any problem on Friday? Can anybody respond, please?
No, ma'am.
So Friday, you can tell me your timings whenever you are free.
Okay, ma'am.
Afternoon?
Yeah, ma'am. Afternoon.
Around 2 or 1?
2, madam.
2?
We have a class, ma'am.
Okay.
Ma'am, after 7 o'clock is better, ma'am. In the evenings.
In the evening. 7:30 fine?
Yes, ma'am.
Okay. 7:30 and for 10 minutes only. Okay.
Yeah, ma'am. Okay, ma'am.
Okay then.
In Teams,
Friday. What?
platform, ma'am. In which platform, ma'am?
On MS Teams only, and first 4 modules. Your syllabus is 4 modules. Okay.
Okay, ma'am.
Set it for 15 minutes, ma'am.
What?
Can you set it for 15 minutes, ma'am?
No, I will extend that. Means I will set for 15 minutes only, like 3 minutes prior to that and 2 minutes after that. Okay. But you just consider this as 10 minutes. That's it.
Then Friday 7:30. Right, ma'am?
7:30 Friday. And
Okay,
first
ma'am.
4 modules. Okay.
Ma'am, what will be the number of questions? 10?
That may be 5 or maybe 10. I will decide. If 5 means just it will 2 marks, and if 10 means 1 mark.
Okay, okay, ma'am.
Most probably 5 questions only.
Okay, ma'am.
Ma'am, whether it is MCQs, ma'am.
What?
It is MCQs, ma'am. Multiple choice.
Yeah. On MS Teams, no other options. MCQs only. Everybody mark your attendance.